So question number 14 on page 112. So this is a question here. Again, a ball is projected vertically upwards with a velocity of 25 meters per second from the bottom of a tower. A boy who is standing at the top of the tower is unable to catch it when it passes him in upward direction. But he catches the ball when it reaches him again after 3 seconds when it is falling. Find the height of the tower. So again, let's have a simple diagram to understand what the question is. As we see from the diagram, the ball is projected from the bottom of a tower, that is point A, with the velocity, upward velocity of 25 meters per second. The path of the ball is from A, it goes vertically up. So when it is passing this point P, where the boy is, he is not able to catch. The ball keeps going up, reaches the point B, maximum height, and again it starts falling. When it comes back again to point B, that's the time when a boy catches the ball. This problem is very similar to, assume that you are standing on a building, you are playing cricket, and ball falls to the road. When somebody throws the ball from the bottom, it's more difficult to catch when it is going up. It's much easier to catch when it is falling down. That's what the question is. So let's see how we solve this question. What are concepts involved? It involves two simple concepts. One, maximum height above a point is equal to velocity at that point square divided by 2g. That is u square by 2g, u being the velocity at that point. So here at point A, the maximum height reached above point A will be equal to 25 square by 2g. And second thing is related to time of flight. That is the time to return to the same point. That is equal to twice the velocity at that point divided by g. So here what we observe at point P, where the boy is standing, top of the tower, the ball goes up to point B and again comes back to the same point. So time taken by the ball to go up and come back is equal to the time of flight at point P. So maximum height and time of flight. Using these two concepts, this question can be easily solved. Let's look at what the solution would look like. As we have seen, A to B, that's the maximum height, with reference to point A will be equal to u square by 2g, u being the velocity at point A. We substitute this value, we find AB is equal to 125 by 4 meters. Time of flight observed at P is equal to 3 seconds. It takes 3 seconds to come back to point P. So which has to be equal to twice 2 into u into g. Now again, what is this u? U is the velocity at point P. So here, time of flight is 3 seconds. So when you substitute this value, find the value of u equal to 15 meters per second, which means the velocity at point P is equal to 15 meters per second. Once we know the velocity at point P, we can find out the maximum height with reference to point P. The maximum height observed at point P, that will be equal to velocity at point P square divided by 2 into z, which comes to 45 by 4. So what is the height of the tower? This height of the tower A to P will be equal to AB minus PB. AB minus PB, which is equal to, we substitute those two values, we find 80 by 4 or 20 meters. Thank you.